Hi guys, hope you all are doing good. So in this lecture we are starting one of the most important subjects in computer science, design and analysis of algorithm. So if you are preparing for gate, placements, coding interviews or competitive programming, this subject is extremely important. So in this lecture, we will learn what is an algorithm, characteristics of algorithm. So why we analysis algorithms, some real world examples and algorithm design techniques. So without any delay, let's begin. So first we're gonna see what is an algorithm. So an algorithm is a step-by-step procedure used to solve an problem. So in simple words, an algorithm is a set of instructions that tells us exactly what to do and in what order to do. So for example, think about making a tea. So you need to follow some procedure to making a tea. So first you need to boil water and you need to add tea powder and you need to add sugar and you need to add milk and boil for a few minutes and you need to filter it and serve. So these steps forms an algorithm for making a tea. So similarly, a computer also need instructions. So algorithm provides those instructions. So let me write the definition for algorithm. So an algorithm is a finite sequence of well-defined steps used to solve a problem. So let me give a real life example. Imagine you want to go from your home to your college. So you may follow these particular steps that first you will leave your home and then you will reach us the bus stop and you take the bus and later you go down to your near college and you go to your campus by walk. So this sequence of steps is also an algorithm. So algorithm is everywhere around us. So let us see about characteristics of algorithm. So these are the characteristics of algorithm: input, output, definiteness and finiteness and effectiveness. So let us see one by one. A good algorithm should have the following characteristics as I mentioned. So first we're going to see input. An algorithm should accept zero or more inputs. So for example, to add two numbers, we need two inputs. Suppose, let me write a equal to 10 and b equal to 20. So this is the examples for input. So now we're gonna see about output. So an algorithm should produce an at least one output. For example, let me add these two numbers a plus b, that equal to 10 plus 20 equal to 30. So the output is 30. So this is the output. So let us see about definiteness. So every step should be clear. I mean, every step should be clear. So, for example, if you ask to me to add some numbers, you didn't mention properly that which numbers I should add. So, for example, the good instruction is add a and b. That means add 10 and 20. So each step must be very clear and defined. So if I suppose I told to add random two numbers, it will be not a particular defined. If I clearly mention that you need to add 20 and 30, so set me at 20 and 30, you will get 50. So these instructions are clear. So the instructions must to be clear. So let us see about finiteness. So the algorithm must stop of a finite number of steps. It should not run forever. So example, you're counting from 1 to 10 stops. After reaching 10, you're gonna stop. Suppose if I told to count from 1 to infinity, it takes long time. That process is infinity. So the algorithm should be finiteness. So let's see about effectiveness. Every step should be simple and executable. The computer should be able to perform the step easily, not difficult. So it should be clear that the computer should be able to perform the steps. So now we're gonna see why we analyze algorithms. So now you may ask me that if an algorithm solves the problem, why do we need analysis? Because not all algorithms are equally good. Some algorithms are faster and some algorithms use less memory. So let us understand with an example. Suppose we have two students. So let the first student is A and the second student is B. Student A searches for a book in a library by every shelf. Means student A is checking every book to find his required book. So when it comes to case student B, he uses a library catalog and directly goes to the correct shelf. So both finds the book. Means student A will find the book and student B also find the book. But student B is much faster. So similarly, different algorithm solves the same problem with different efficiency. So analysis helps us to choose the best algorithm. So let me write the goals for algorithm analysis. So these are the goals of algorithm analysis. So reduce execution time, reduce memory space, and improving efficiency, handling large amount of data, and build scalable applications. So suppose let me give real world examples for good algorithms. So these are the some real world examples of algorithm. Let us see one by one. So first one is Google search. When you search something on Google, algorithm decides which page should appear first. So the second one is Instagram feed. So when you open Instagram, the algorithm decides which post you need to see first. So the third one is YouTube recommendation. So algorithm suggests videos based on your interest and watch history. I guess this video also recommended by YouTube, I think. So the fourth one is GPS navigation. So algorithm calculates the shortest path to a destination. So this is the GPS navigation, and we're gonna see about online shopping. So algorithm recommend products that you may want to buy. So algorithm are part of our daily life. So let us see algorithm design techniques. So these are the algorithmic design techniques. So let us see one by one. So first we're gonna see brute force. So brute force means trying all possible solutions. So example, trying every password combination. Suppose you have created a 4-digit password in your mobile. On a particular day, suppose you have forgot your 4-digit password. So you will try every possible outcome which will suits that 4 digits. So it will take some time, but it actually works. So it is simple but often very slow. So the second one is divide and conquer. So it means breaking a big problem into smaller problems, solving them separately and combining the all answers. So that means if you have a big problem and you divide it into small problems and solving each of them, and finally you will combine all the answers. So the best example for divide and conquer is Metslot. So the third one is greedy method. So it means making the best choice at every step. So example, activity selection problem. So the fourth one is dynamic programming. So stores previous results and reuse them. So this avoids repeated calculations. Example, Fibonacci series, the best example. So the fifth one is backtracking. So exploring solutions and return when a path fails. So example is Nque's problem. So the sixth one is branch and bond. So use it for optimization problems. So searching intelligently while avoiding unnecessary paths. So this is what we have learned today. We have learned what is an algorithm, characteristics of algorithm, and why algorithm analysis is important, and real world applications. So I hope this lecture is useful for everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.